Hi guys, so we're going to review chapter 15 and 16 today. You should be watching this on May 17th, and so let's go ahead and get started. The chapter 15 and 16 were all about periodic functions. Remember that periodic functions are functions that repeat after a given amount of time, right? So it happens again and again. Chapter 15 was more of an introduction and also using our unit circle. If you don't know how to use your unit circle, we're going to have a little bit of a reminder here and here, but make sure that you look back in those notes to remind yourself how to do those things. So let's go ahead and get started with this question here. It says, determine the amplitude, period, and midline of this graph. I'm going to start with the midline because I think it's easiest to see. The midline, remember, is where the middle of our wave is. So it looks to me like that middle is at 3, right? And my midline then is at y equals 3. Remember that it's an equation because it's a line. Now, moving on to the amplitude. The amplitude is from the midline to the top, right? So that midline that I just drew to the very, very top is 1, 2, 3. So the amplitude must also be 3. Now you can also do the midline down to the bottom, 1, 2, 3, and you get the same answer. Or you can count the total height from here to here, so that's 6, and then you cut that in half to find the amplitude. Okay, so many ways to find the amplitude there. Lastly, the period. I'm going to shade the period a different color. So we are, you want to shade for an entire wave. So I'll start here, so it's easiest to see for me anyways. And I'll go back till we get to the very top. Well, and it looks like we went from 0 to 6, so then the period must be 6. Now you don't have to start here and end here. You can start and end wherever you want. So, I mean, let's say, sorry, let me adjust a little. Let's say you wanted to start somewhere else. So we'll start here, I guess. So you wanted to start here. You still shade for an entire wave, so there to there. Just makes your counting a little bit weirder, I think. So this starts at -3. So it means we have 3 till we get to 0, and then it goes until 3. So you still get 6. That's just a different wave that you're looking at, but it's periodic, so it shouldn't matter. It should repeat over and over. Alright, I'm going to head over here, and we're going to start solving equations. Alright, first one is pretty simple. It's not squared at all, so you don't have to worry about that. But we did start both of these like the same way, so I'm just going to replace the cosine with a variable so I don't have to worry about the cosine x. So I'll let cosine x equal c. Why not? Doesn't matter what you pick. So 2c plus 5 equals 6. And then I'm just going to work to get c by itself. So first thing I'm going to subtract 5. Subtract 5. So I get 2c equals 6 minus 5 is 1, sorry. And then the last thing I'm going to do is divide by 2. And I get c equals 1/2. And that's fantastic, but it's not an answer. C was cosine, right? So I'm going to replace that with cosine x equals 1/2. And then from there I'm going to go to my unit circle. So on my unit circle, I'm going to look for where cosine equals 1/2. Cosine, remember, is our x values, so 1/2 there. So I've got pi over 3. And it's also right here at 5 pi over 3. So those are my two answers. Great. And we're done with that one. Next one, we're going to start the same way. I'm going to replace sine with just some variable so I don't have to worry about the fact that it's actually sine x. So I'm going to say, let me change colors for you guys. Let sine x equal, I'm going to use n. So 2n squared plus 3n plus 1 equals 0. The only reason that this one is a little bit trickier than the last one is because we have to factor, right? We've got two terms. One's n squared, one has just n. There's no way that I'm going to get rid of those. So I have to factor in order to solve. And a little bit more difficult factoring here because of this 2 out, because of this 2 out in front, I'm going to have to have a 2n and an n, right? So that when I distribute, if I'm to distribute, I'll get 2n squared. The really nice thing is that there's only one way to get 1. It's got to be 1 and 1. And then I just need to figure out my signs. They have to be the same sign in order for us to get a positive 1 when we multiply these. So they're either both positive or both negative. And then if I look at my other sign of positive 3, they must both be positive. Now, if you don't know if you factored it correctly or you don't believe that I factored it correctly, I completely understand. You can just go ahead and distribute. So FOIL, right? This to this, this to this, this to this, and this to this, and make sure that we get what we started with. And in this case, we will. So this thing equals 0. And we're going to end up with two answers here. We're going to end up with whenever that first factor equals 0, and whenever the second factor equals 0. So I just have to go ahead and finish solving for n. I'm going to subtract 1 on this side. 2n equals negative 1. Divide by 2. N equals negative 1/2. And then over here, a little bit easier, subtract 1. So n equals negative 1. Now that's great, but just like up here, we didn't care what c was. We don't care what n is. N was representing sine, so I'm going to replace that. Sine x equals negative 1/2, and sine x equals negative 1. And with that, I'll go to my unit circle. So I'm going to find the places where sine equals negative 1/2 and where sine equals negative 1. Sine equals negative 1/2 here, 7 pi over 6, and also over here at 11 pi over 6. So I've got x equals 7 pi over 6 and 11 pi over 6, and then sine equals negative 1 right here at 3 pi over 2. Okay, and we are done with that one. So much better. Alright, moving on to the last one that requires us to do a lot of calculation. This is a Pythagorean identity thing. It's from 16.1b, I actually think all three of these are from 16.1. 1a, 1b, 1b. So our Pythagorean identity said that sine x squared plus cosine squared equals 1. And then in this case, I've given you cosine and I'm asking for sine. So I'm just going to take the value I got for cosine and plug that in. And then I'll go ahead and solve. First thing I'm going to do is square this. Now, the negative doesn't really matter here, because when I square it, it's going to become positive. We'll take care of that with the 3. So, negative 3 squared is positive 9. Oh, that should be a plus sign, sorry. 4 squared is 16. Equals 1. And I'm trying to get sine by itself, so I'm going to subtract 9 over 16, because it was addition, and if it's a terrible addition sign. And now I'm at, let me block this off. Now I'm at sine squared equals 1 minus 9 over 16. Now I've got a fraction, right? A whole number being, or 1, yeah, a whole number, subtracting a fraction. So I need common denominators here, so I'm just going to write 1 as 16 over 16. That way I've got these common denominators, but 16 over 16 we know just equals 1. So I haven't changed that at all. And then we'll get 16 minus 9 is 7. And that's sine squared. I'm going to rewrite this. Kind of got lost there. That's sine squared. So in order to get sine, I'm going to just take the square root of both sides. I can't do the square root of 7, so I'll just leave it as square root of 7. I can do the square root of 16, which is 4. The only last thing to do here is to check quadrant 3 and see if sine is positive or negative. So I'm going to look at my unit circle. The unit circle I gave you to use on the test is labeled, right? So it says quadrant 1, quadrant 2, and quadrant 3. You don't need to memorize that. Here we are in quadrant 3. Looks like all of my sine values are negative. So I'm just going to throw a negative in front of that answer. And we're done with that one. Alright, last one is a problem situation about the depth of water near the coast. It's modeled by this function given here. And a bunch of questions are asked about it. Before we jump into these questions, there's a possibility, right, that you might be asked to find the depth of water at time 8, right, at 8 a.m. And so we know we'd be plugging 8 into here. Please go into your notes and remind yourselves how to do that. So I think it's like 16.3 probably. Remind yourself how to use your calculator, especially when we've got a bunch of fractions going on here. It'll be super helpful, I promise. Okay, so it says find the amplitude, period, and vertical shift. Now, amplitude is always the thing directly in front of the trig function. So in this case, the amplitude is 4.8. I'm going to jump and do the vertical shift because that one's also super easy to identify. That vertical meaning like up or down. And the up or down part of this is right here, right? So we've got a vertical shift of 5.8. And lastly, to find period, you're going to use this number right here. And I say use this number because it's not that number. To find period, remember we do the reciprocal of the b value, or 1 over b times 2 pi. In this case, b is 1/2, or 0.5. I'll multiply by 2 pi, and I'll do 2 pi over 1, just so we can multiply those fractions really easily. 1 times 2 pi is 2 pi. 0.5 times 1 is 0.5. And so I'll leave it in terms of pi. My answer will have pi in it. And I'll just do 2 divided by 0.5, and I get 4. So our period here is 4. That is it for chapter 15 and 16. I would caution you that there is a bunch of questions because it was 2 chapters. There are a bunch of questions about this on your final. So really take today as an opportunity to study chapter 15 and 16 and really familiarize yourself with things you may have forgotten. It's incredibly important. Biggest chunk of your test is definitely 15 and 16. So prepare yourselves. Please work together. Have fun. See you tomorrow.